Unit 8.3 is the converse of the Pythagorean theorem. The converse of the Pythagorean theorem. The Pythagorean theorem says, if we put it in if-then form, if it is a right triangle, then c squared equals a squared plus b squared. The converse would say, if c squared equals a squared plus b squared, then it is a right triangle. So we can tell whether something's a right triangle or not just by seeing if the longer side square is equal to the sum of the smaller two sides. And then we're going to talk about, well, if it's not a right triangle, then what is it? Well, it's either got to be an acute triangle or an obtuse triangle. And we'll talk about that in just a second. Before we do that, we have to know whether the thing's even a triangle or not. Well, to be a triangle, the sum of any two sides, or the sum of the smaller two sides, must be larger than the third side. Example, could the numbers 2, 3, and 5 be the lengths of the sides of a triangle? Well, if we take the sum of the smaller two, we get 5. The larger one was 5. Those are equal. The sum of the smaller two is not bigger than the third one, so this is not going to be a triangle at all. In fact, if we took that larger side, 5, think about it like this, and we had a piece that was 2, you could take a 5-inch piece and you could take your little protractor. You could take your little compass, excuse me, put the little pointy thing there and make an arc, right? And then you could make this other one 3 inches, put your little pointy thing in your pencil at 3 and make an arc. I probably made that too long. And if you made an arc, if one was 3 and one was 2, then they would just kind of, so you would just sit there and lay on top of it. So it'd never make a triangle, you see, because they wouldn't hit above it. If I had a situation like this where the sum of the smaller two was bigger than that, in other words, we had a 5 and a 7, uh, that didn't make sense. Let me say that again. If we had a situation where the smaller two had a sum of 5, the bigger 7, it's not larger. Look what would happen there. If we had the larger that was 7, and we had a piece that was 2 spinning, and we had a piece that was 3 spinning, since together they're 5, there would be a 2-inch gap where they didn't hit. So they just kind of spin around and never make a triangle. Here, if we take the smaller two, we get a sum of 5, and this is 4. The sum of the smaller two is greater than the other, so it is a triangle. And so we could kind of see if it was 4 and we, excuse me. So, yes, this is a triangle. If we had a piece that was 5, excuse me, I'm going to get this right in a minute. Excuse me, I'm hitting a lot of keys. Let me just pause it and straighten it out. Okay. If this was 4, and we had a piece that was 2, and we made an arc, and we had a piece that was 3, and we made an arc, those two arcs would hit above, and so it would make a triangle because the sum of the smaller two is greater than the length of the third. Okay, so that tells us whether it's a triangle or not, but it doesn't tell us what kind. So to be a triangle, the sum of the smaller two sides must be larger than the length of the third side. To see what kind it is, I need to pause a second. To see what kind of a triangle it is, we're going to compare the large square to small square plus small square. It's like checking out the c square and a square plus b square. If they come out equal, then it is a right triangle. If they do not come out equal, it's not a right triangle. And then what do you do after that? Well, think about that protractor with the pencil and the pointy thing. if you opened it up just right and you had a right angle, then this would be the hypotenuse, c square, would be equal to a squared plus b squared. But what happened, that's when it's equal, right? But what happened if you made it longer than? C squared came out bigger. Well, for that to be bigger, you would have had to open up your protractor wider, your compass wider, excuse me. And so it would have had to been an obtuse angle. So if c squared is bigger than it's supposed to be, then that right angle is bigger than it's supposed to be, which means it's not really a right angle, it's an obtuse angle. Or if the c square comes out smaller, it means that it wasn't opened up as wide. And so then this angle, rather than being a right angle, would be an acute angle. So if the square of the larger side is bigger than the sum of the squares of the smaller two sides, it's obtuse. If the square of the larger side is equal to the sum of the squares of the smaller two sides, it's a right triangle. Or if the square of the larger side is less than the sum of the squares of the other two sides, then it is an acute triangle. So let's look at these examples, okay? First of all, we got to check to see if it's a triangle. If the sum of the smaller two sides is not greater than the third side, then it is no triangle at all. So 2 plus 3 is 5. That is greater than 4. So yes, it is a triangle. That tells us it is one. To see what kind it is, we compare the square of the larger side to the sum of the squares of the smaller two. 4 squared is 16. 2 squared is 4. 3 squared is 9. 4 plus 9 is 13. The square of the longer side is bigger, greater than the sum of the squares of the other two sides, so it is an obtuse triangle. The next one, the numbers 3, 4, and 5. We compare the sum of the smaller two. It is greater than the length of the third, so yes, it is a triangle. To be a triangle, the sum of the smaller two sides must be larger than the length of the third side. To see what kind it is, you compare the larger side square with the sum of the squares of the other two sides. So 5 squared is 25, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, 25 is equal to 25. The square of the longer side is equal to the sum of the squares of the smaller two sides, so it's a right triangle because it satisfies the Pythagorean theorem. The sum of the smaller two is greater than the third, so yes, it is a triangle. To see what kind, we take the longer side square, compare it to the sum of the squares of the shorter two. 6 squared is 36, 4 squared is 16, 5 squared is 25, 25 plus 16 is 41, 36 is less than 41. The square of the longer side is less than or smaller than the sum of the squares of the other two sides, and so it is an acute triangle. So this is like the compass opened up so that the square, let me move that to the middle. This is like the compass opened up so that the square of the longer side is equal to the sum of the squares of the other two sides, Pythagorean theorem. Here the larger square come out bigger, which means that that had to be opened up wider. So it's an obtuse angle. Here the larger side square came out smaller. So it was opened up not as much as 90. And so it's an acute triangle. Okay? Any questions on the converse of the Pythagorean theorem? So to be a triangle, the sum of the smaller two sides must be larger than the length of the third side. To see what kind it is, you compare the larger side square to the sum of the squares of the smaller two sides. If the larger side square is bigger than the sum of the squares of the smaller two sides, then it is an obtuse triangle. If the square of the longer side is equal to the sum of the squares of the smaller two sides, then it is a right triangle. If the larger side square is smaller than the sum of the squares of the other two sides, then it is an acute triangle. The converse of the Pythagorean theorem. Okay? Daily work unit 8.3. Let's just look at number 4. Number 4, we want to see if it's a triangle, so we compare the sum of the smaller two to the larger. The sum of the smaller two is 9. That is greater than 6, so that proves that, yes, it is a triangle. But it doesn't tell us what kind. To see what kind, we take the larger side 6 and we square it, and we compare it to the sum of the squares of the smaller two sides. So we compare 6 squared to 4 squared plus 5 squared. 6 squared is 36, 4 squared is 16, 5 squared is 25, 16 plus 25 is 41, 36 is less than 41. The larger side square is smaller than the sum of the squares of the other two sides. Since that is smaller, it didn't open up as wide to 90, and so it is an acute triangle. Any questions on that? Okay. Let's just look at number 7. Number 7, to see if it's a triangle, we take the sum of the smaller two, 4 and 4, compare it to the larger 6. We get 8 is greater than 6, so yes, it is a triangle. We know it's a triangle because the sum of the smaller two is greater than the larger. Now, to see what kind, we take the larger square and we compare it to the sum of the squares of the smaller two. 6 squared is 36, 4 squared is 16, 4 squared is 16, 16 plus 16 is 32, 36 is greater than 32. The larger side square came out bigger, which means it opened wider than 90. Bigger than 90 is obtuse, so it's an obtuse triangle. Any questions on number 7? Okay. These are some constructions we're going to allow you to do on your own. You can make up your own numbers to see that it works. You could use some of the numbers above if you wanted to, or you can make up your own numbers. Okay? It says use the diagram and a protractor and the Pythagorean theorem to reach conclusions. What we're doing is discovering relationships within 45, 45, 90, and 30, 60, 90 right triangles. We want you to measure accurately. The blanks, you know, are the rules for the next page, which would be Unit 8.